Hello everyone, I'm Josh, a solutions architect from Melbourne, Australia, and joining me on stage today will be Ankit from National Australia Bank. Unfortunately, Robert couldn't make it here today to the event. Today we're going to share this story of the migration of some Oracle apps onto AWS. Before we jump in, we're going to cover off who NAB is. We're going to cover off some business objectives and the reasons for making the changes and what challenges NAB were looking to solve. We're then going to hand over to Ankit, who's going to cover some of the technical aspects of the migration. We're going to talk about scalability, security controls, performance tuning, cost savings. And then I will close out and I'll talk about both the results achieved and what's next for NAB. National Australia Bank, or NAB for short, was formed in 1981 after the merger of two banks in the mid-1800s. They are one of the big four banks in Australia, with their head office in Melbourne, Victoria, employing about 32,000 employees and serving more than 8.5 million customers. As an enterprise, they run over 2,000 applications, a mix of on-premises, including mainframe, cloud infrastructure and platforms, and software as a service. As a bank, about 5 years ago, their CTO, Patrick Wright, gave a target to actively migrate 80% of their applications to the cloud by 2023. Today, they are already sitting at 71% already moved. The project that we're talking about today was done by a Treasury technology business unit that consists of about 40 people. They look after the data for the finance, risk, and a few other business units that are also consumers of their data. They look after so what we've got here is, in the centre, the business unit that we're talking about, and they do funds transfer pricing. So they look after the price of the interest from money lent and money savings. So on the value side, you deposit money, the business unit that gets the deposit hands the money to Treasury. Treasury pays the business unit a rate back, and the business unit will pay you interest. And the difference is the rate we pay the customer and that you get from the Treasury unit. Okay, so that's where the profit comes from the difference between the lending and the savings. As a central technology unit, they have an inherent risk on any changes to the environment, not just from the upstream and downstream systems, but also to the market and the Reserve Bank of Australia, which needs to get the calculations that they've got. So there's reports that go off in various different directions everywhere that the whole business is relying on. So the role here is to calculate the transfer pricing, the various risk metrics, and the financial postings to a general ledger for the accounting and analysis purposes. We've got 5 applications that are used here under 2 broad Oracle application sets. We've got the OFSAA application, which is the Oracle Financial Services analytical applications, so funds transfer pricing, profitability management, and general ledger reconciliation. This receives all the transactions, calculates the rates, risks, etc. We've then got the ebusiness-suite, which has the financial hub, the financial accounting hub, and the financials general ledger, so where the general ledger is posted to. So this is the financial accounting, resolving anything from simple to complicated accounting scenarios to analyse the postings. Data is sourced daily from over 20 systems across the bank, running about 900 batch jobs and 2,100 application tasks. Because of the granular level at which NAB want to do the processing and postings, millions of transactions flow through the system daily. So what were the business objectives here? Why did NAB want to move? As we talked about just before, NAB were aiming to move, or are aiming to move, 80% of their applications into the cloud. And this application was running on aged Oracle Exadata infrastructure on old versions of Linux. It was getting to the end of life support, and it was lacking a lot of business functionality that newer versions of the software could provide to the business. But because the environment was shared with other teams, the Oracle Exadata, so it made coordinating upgrades quite difficult. Supportability was therefore hard, and it took months to provision new environments on the Exadata and related infrastructure due to the on-premise support model, which the team had limited access to. They had no admin access to kill sessions, unlock accounts, etc. So, as a bank, under this new technology management and the moving to the cloud, this was chosen as a project. NAB approached AWS. They had some targets that they wanted to achieve as part of the migration. They wanted to uplift to the latest versions and in the process start using more secure encryption that wasn't available in older versions, so we're talking versions before TLS, etc. So to bring things up to their current security standards. They wanted to ensure that the environment remained highly available since they provide a core service to the business. And they wanted to create a process so that they could quickly spin up environments to test a patch or change what they wanted to apply, or any changes they wanted to apply. While doing this, they were thinking about scalability and better performance. They were also aware of the size of their environment, with their database sitting at around 20 terabytes. So we're not talking like, hey, let's just plug a little hard drive in and move it. A little bit bigger than that. So with the cloud making it easy to spin up environments at scale, they then also needed to be cost aware. So they were looking at how can they do this in a cost-effective fashion with high availability and better performance. Ankit, would you like to cover off some of the technical bits here?
Yep. Thanks, Josh. Hi, everyone. I am Ankit Kumar Singh, Senior Consultant Solution Design working for National Australia Bank. So let's deep dive and try to understand how we were able to successfully migrate these Oracle apps into AWS Cloud. So as Josh mentioned, we had two main applications. This is the pre-migration architecture of the first application, which is Oracle Financial Services Analytics, in short, OFSAA. So it was having 3-tier setup with TCP database connection with most of the enterprise tools. We have to manually do the disaster recovery if needed, and historical data lives within the same database instance, which was causing the scalability issues. There was no automated process to create the new environments if we need to do any sort of patching or we need to apply some product patches. So now this is the architecture of OFSAA application we have built into AWS Cloud. So it is a 4-tier setup here to have the standalone API server. We utilize AWS auto scaling group to make sure that we provide high availability and automated disaster recovery to the applications. We have independent API server as well to make sure that we can scale API alone and provide near zero downtime whenever we try to do any operating system patching or we want to deploy any API, new version of the API. To offload most of the database admin work and enable high availability, we use AWS RDS, Oracle Database as a Service, with multi-AG setup. There are a lot of business reports and data analysis queries from the business users and operations team. So we wanted to make sure that we are not impacting any of the big critical business report because of the batch processing, or any of the batch processing is not being impacted because of the queries run from the users. So we had AWS RDS Oracle Read Replica for reporting and as well as data analysis purpose. There are we process more than 50 million of record daily, and we we wanted to make sure that our main tables are very light for the best performance. So we pushed our archival historical data into AWS S3 bucket to make sure that our main processing tables are very lean and our batches are going through fast. We use AWS SDK, Python scripts, Python and other libraries to which we run onto EC2 machines, and then it pushes the data from applications Oracle RDS to AWS S3 bucket in Parquet file format. We use AWS S3 lifecycle policy to move the data files between different storage class as well for long-term storage to meet the compliance and cost savings. Sometimes we need to access these historical data based on the need. So our engineers use Athena, AWS Athena to query these data files if needed. As we can't instrument these Oracle pre-built C++ services of this application for monitoring, we run shell script in our own in our servers, and it provide the status. And we use that logs with help of AWS CloudWatch agent. We push those logs into the AWS CloudWatch, and then we set up AWS CloudWatch alarm and push the SNS notification to our NAB central account, AWS account, to create the incident. So all the secrets are being stored into AWS Parameter Store with secure string, and we encrypt those with the CMKs. Whenever application and script need those passwords, they use appropriate IAM role to get the passwords. Along with all this, we run our ETL tool as well into another AWS account. We use AWS EFS as a data landing zone there. We wanted to attach this particular file system to our application server as well for our operations team. So we attach this EFS cross account to another account, and that's where our EC2 machines automatically read its availability zone and try to identify its EFS IP address, and then we use EFS utils to connect those EFS into our application server. So this is the second application Josh was talking about, and this is Oracle ebusiness-suite. So before migration, it looked like this. It was two-tier setup where database was shared with the first application we talked about with OFSAA. It was again TCP database connection with enterprise tools, and there was no automated process for disaster recovery, and we can't create new environments easily there. So in AWS Cloud, we have decoupled this application to have independent infrastructure. So it is now hosted within a separate database, separate AWS account with its own database. We again use AWS auto-scaling group with launch template for high availability and automated disaster recovery of the application server. We have used AWS EFS here to provide the shared file system to the application server across multiple availability zone. As EBS business suite need database operating system level access during its setup, we really can't use AWS RDS. And that's why we host our own database on EC2 machines. We push Orman logs from EC2 machines to AWS S3 for the backups and recovery of the database if needed. AWS S3 lifecycle is being used to move those old Orman backups into the AWS Glacier and delete later for the cost saving purpose. And here also we use AWS Parameter Store for the password, and application and scripts uses those parameter store to read the password if needed. So let's try to understand how we were able to achieve high availability and disaster recovery for Oracle database running on Amazon EC2 machines. So here we have primary database running on EC2 machine in AG1, and we have secondary database which is again running on EC2 machine in AG2. We have Oracle Data Guard set up in between, which is syncing both primary and secondary database in real time. We have Observer Server EC2 machine, which is running in another third AG, which is AG3. So Observer is continuously monitoring health checks for both database and pushing the logs into AWS CloudWatch, which is indicating that which database is currently acting as a primary. And it will initiate automated failover to the secondary database if primary database is not available. We create CloudWatch matrix based on the logs and set up a CloudWatch alarm whenever failover happens to secondary database. We have Route 53 set up with failover routing policies. Route 53 health check is integrated with CloudWatch alarm to provide the consistent and accurate IP address of the database on the DNS resolution. Applications, users, and systems will use consistent connection string irrespective of which database is serving the request. So we were using WebLogic as a web server in our on-prem setup. Now to save the license cost, we moved to Apache Tomcat. But we soon understand that Tomcat is using plain text password data source configuration in their configuration files. And this is just a security compliance issue. So we decided to write a Java-based custom extension for Tomcat JDBC data source factory with help of AWS Professional Services team. Now we provide AWS Parameter Store name in the Tomcat data source config, and Tomcat calls this custom Java extension library, which in turn calls to AWS Parameter Store to read the password with appropriate IAM roles. And then it injects that password into Tomcat so that Tomcat can securely connect to the database. So this is very secure Tomcat data source implementation, which can be used across the bank. Security is very important aspect when we move into the cloud world. So we wanted to make sure that we connect Amazon RDS over encrypted channel via TCP only. JKS, which is Java Key Store, needed AWS RDS certificate into its key store to connect securely. To achieve this, we wanted to create automated process. Whenever new EC2 machines is being created, JKS is ready to with all the certificates for database connection. So on high level, we create client key store. We take AWS RDS regional certificate and convert it into the DIR format so that we can import that into the key tool. We update SQLnet and tnsnames.ora files with TCPS configuration like port, protocol, SSL version, and its wallet. We pass this JKS information into Oracle application using Java argument with help of operating system user profile. We fully automate this process using EC2 user data scripts. So now whenever new EC2 machine is being created, it's ready to connect AWS RDS securely. Performance is very crucial part when we migrate to a new platform. So first, we analyzed our Oracle AWR report from on-prem. Oracle AWR report is native way to understand CPU, memory, and IOPS for an Oracle database. It provided us an approximate instance class and size. Then we took a long processing job and started our experiment there. And we found AWS RDS DB-R5 8x large was the best fit instance class to match up our performance. But we could see some IOPS constraint based on the queue depth. So we increased our storage to 5 terabyte to have the more IOPS. It has grown to 20 terabytes now due to the data volume. We saw a lot of frequent redo log switches in AWS RDS performance insights. So we increased our redo log size to 160 GB. SQL tuning and joining were taking time due to a small default temp table space. So we have increased the size to 200 GB. We did some SQL tuning as well as profiling with help of Oracle SQL Optimizer. And do look for index and table scan for bigger and partition tables. So the result we have achieved is we have got better performance than on-prem when we are running into AWS Cloud. So post-migration, we started working on the cost optimization, and we understood that Spot instance can significantly reduce our environment cost. We run less critical servers like Bastion, Web on a Spot instance in production with help of AWS Autoscaling Group support for Spot instance. As we apply product patches from Oracle and perform some testing in dev and test environment, we utilize AWS Spot request of type persistent with the interruption behavior as stop to make sure that those patches are not lost whenever there is a resource crunch from AWS point of view. Because we run almost all the non-prod instances on Spot, along with a couple of less critical servers on production server, it provided a significant cost reduction for us. And it keeps our boss happy as well. So consistent and production-like environments are important to reduce the incidents. As Oracle application is not easily scripted for automated installation or patching due to the way Oracle distributes the software, for us to script the automation that works for us, we made the conscious decision to create a simple base server where we install the application once. Then we generate the OS artifact from there, and we keep that into AWS S3 bucket. We take the AWS RDS snapshot as well, which contains the data model as well as seeded product entries. Now using these artifacts and Terraform as infrastructure as code, we can now start automating environment creation process. So engineers need to create the new environments for developing new features, integration testing, or performance testing, and more. To do this, we created a JSON document as an input for our Terraform. Now we just need to answer a few generic questions like, do you want multi-tier setup? Do you want auto-scaling group or a Spot instance? How about RDS read replica? We need to push this JSON file into GitHub, and Terraform will build the environment using this JSON file. Rest of the 100+ variables like VPC ID, tags, AMI ID, and others will be automatically picked by the Terraform based on the variable's default value or locals or data calls. So once our input is ready, we have built our own custom CLI on top of Terraform, which generates the Terraform code automatically based on the template. We run init command, which will set up our Terraform backend and securely push the state file into S3 bucket. Next, we will run the config command to create the Terraform plan. it will read the input JSON we have set up, and it will create the plan, whatever resources is going to create into AWS Cloud. Once we are happy with the plan, we will run the apply command. And this will create all the necessary resource along with all the automations needed for application to set up. We used to take almost 1 to 2 months to create the new environments manually. But now we can create the new environments within 60 minutes with all the security inbuilt and without any manual intervention. So once the environments are ready, we need to patch regularly for security regions. This custom CLI has patch command as well. Terraform will automatically take the latest security patched AMI published from NAB Central Cloud team and then create the new version of the launch template. And once launch template is ready, it will recreate the auto-scaling group to create the new EC2 machines with the new patched AMIs. It's always good to rotate the password as well regularly. This CLI also has the rotate password command. Terraform will rotate the passwords into Parameter Store and recreate EC2 machines to inject the new password into applications. Josh, do you want to talk about what result we have achieved and what next for us?
Sure. Thank you, Ankit. So, what has NAB achieved here? They've met their regulatory compliance. So they needed to meet the requirements of the Australian regulator for banking. They needed to meet APRA requirements, which they did. They delivered business value. They've given version upgrades with new features, and it's easier for them to implement it due to infrastructure as code. National Australia Bank has also improved on the SLA that they can give to downstream systems, with the maximum processing time from data ingestion all the way through to data being available to further downstream systems being improved by 30%. And with almost zero downtime when doing patching and upgrades through the modernisation of their deployment architecture, there's further benefits there. Along with all of this, the use of targeted spot instances has allowed them to do all of this cost effectively. I've been speaking to NAB about assessing RDS custom for Oracle service. So once it hits, or if it hits the top of their backlog, as with any new service, they would do a proof of concept to prove the solution, and document their controls ahead of any implementation and integration into their application deployment. We are hoping that it meets their requirements and works with their specific deployment of Oracle ebusiness-suite, as this will reduce the patching and high availability burden and bring it away from NAB to be managed. They don't want to have to maintain a custom EC2 solution for their Oracle databases. But we'll leave this here as a future story. When looking at which database to choose for your Oracle applications on AWS, start from the right of this diagram and move left. Each of the Oracle apps has a differing requirements. So if your application is compatible with RDS Oracle, use that first. It has the least operational overhead, with AWS managing the bulk of the shared responsibility model. In the case of the Oracle OFSAA application, the analytics one, this worked well out of the box with RDS Oracle. It was identified then that the Oracle eBusiness application would not work with RDS due to the specific Oracle database requirements. So during the build of this deployment, the RDS custom offering was not yet available. So as such, NAB had to do their custom build for a highly available Oracle on EC2, which had many complications. So the things that meant they needed to use EC2 included the Oracle eBusiness-suite needing an auto-config script that needed to be run with admin access. They had a patch script as well, similar requirements, and an environment cloning script. There was also a database context file which needed to be put onto the database box. So the requirements from this deployment were fed back to the product team for RDS Custom as we were progressing, but the timelines were not aligning. As such, patching and high availability are still managed by National Australia Bank. From the learnings of building Oracle on EC2 for high availability, the professional services person that was working with NAB, Vikash, has posted a blog article on how to build a high availability setup. This setup is similar to what NAB have. It's not exactly the same, but it's similar, following the same concepts. But be aware that Oracle does not support fast start failover for the ebusiness-suite. National Australia Bank spoke to Oracle support to try and understand why fast start failover wasn't supported and only manual failover with DataGuard. And based on their conversations with Oracle, they've got some further manual processes that they run whenever there is a failover. So be aware, it's not a supported configuration from Oracle if you're going to do this for this particular application. So each of them have their own requirements. Sometimes I see a new announcement and I think, I should speak to the team at NAB about this. It's going to bring big improvements for them, or it solves a particular challenge. So for the RDS, for the e-business side of the application of the solution, the OFSAA side, when the RDS Oracle use of Smart Flash Cache with M5D and R5D was released, I added it to my list to talk to the National Australia Bank team about. The flash cache works well for read-intensive workloads, which NAB have here, that mostly use single block random reads. So that's what gets optimized the most here. So by sizing the cache to hold a portion of the active data that's not sitting into the memory buffer cache, the flash cache can be used as a lower latency cache before reading the data from EBS storage. This reduces the read IOPS burden on EBS and lowers the latency for random access read queries. In this case, by the time I'd spoken to Ankit, he'd not only seen the announcement, but had done a proof of concept of the feature, implemented it in dev test, and deployed it to production for the OFSAA component that was using RDS. Wow. So this is from going from all the way back at the start in the slides when he talked about 1 to 2 months for a change, to less than 6 weeks to do 3 lots of changes here: proof of concept, non-prod, and then production rollout. NAB measured the changes. I've only got a snapshot here of the afterwards. We didn't have the same table for before. But what you can see here is the EBS reads are in the milliseconds, whereas the direct path reads are hundreds of microseconds for the average wait. Okay, so we're talking an order of magnitude difference in the latency. So it's an easy performance upgrade, and as they were already using R5, it was a simple change in their Terraform code to move across to the R5D instance class, and they also had to do a minor version upgrade of Oracle to get the feature. Continuing on to NAB's roadmap, National Australia Bank is building multiple APIs for internal bank usage and for partners. They're building these APIs over the top of the Oracle Financial Services APIs, and by enabling API integrations, they are able to accelerate development of adjacent systems, as well as reduce their reliance on batch file transfers, moving towards continuous data into the system. We're now going to open the floor to questions and answers. Ankit will come up on the stage.